Hello, Mastery Algebra 1. This is Senior Blanco, ready to take you through 5.3b practice. A little bit more on slope-intercept form. Let's do a few problems. We need to find the slope and y-intercept of the graph of each equation. Let's take number 1. If we have y equals 3x minus 5, we need to find the slope. The slope is attached or being multiplied to that x value. So we know that the slope is 3. And then what we're adding to the 3x is our y-intercept, or our b. And our y-intercept is that negative 5. Number 4. Again, we are in y equals mx plus b. So our m is negative 11. And our y-intercept is equal to that positive 6. Let's do one more. Number 7. Now we throw in some crazy decimals. Y equals negative 6.75x plus 8.54. Again, this here being multiplied to the x, that is our slope. So m equals negative 6.75. And our y-intercept is equal to that 8.54. Let's go down to number 10. On 10. We are now going to write an equation of the line with the given slope m and the y-intercept b. Now we got to go backwards. I need to take that m and b and write it y equals mx plus b. We know that the slope is being multiplied to our x value, so we're going to write y equals negative 1x, or you could say negative x, and our b is 3, so we go plus 3. If we take 13, we now have 0.25. So we can say, or write, y equals 0.25x plus 6. If you notice, 0.25 is actually 1/4, so we could write y equals 1/4 x, if we don't like decimals, 1/4 x plus 6. Let's look at 16, because it says, write an equation in slope-intercept form of each line. Now on 16, 17, 18, we have the lines. We need to write it in slope-intercept form. If we look at our graph on number 16, we're going to hopefully find some points that go across the grid. We have a point there. We have a point here. We have a point here. Point there. Point there. And point there. We only need 2 points to write the equation of a line. Okay. The best point that we should look at is this one right here, which is our y-intercept. Our y-intercept sits at 0, 1. So we have 0, 1 for a y-intercept. And then if we notice, since our line is going up and to the right, we know it's a positive slope. And we got to figure out, well, how do we get from here to here and then this way? So if we go a change in y, we went up 2 units. So our change in y is 2. Over our change in x was just 1. So our slope is m equals 2. So put those two things together, we're going to have y equals 2x plus 1. 18 through 24, we're going to write the equation in slope-intercept form of the line that passes through the given points. If we take our point 35 on 19, which is x1, y1, we have 0, 4, which is x2, y2. Notice, I'm going to underline that many times. Okay, 0, 4, if we think back to the things we've been doing here in chapter 5, 0, 4 is a y-intercept. When x is 0 and we have a point or a number for y, we already have our y-intercept. So this is our b here. So if we take our 2 points, we need to find the slope. If we go m equals, take 4 minus that 5 over 0 minus 3, we're going to get negative 1 over negative 3, which is actually 1/3. Okay. If we plug into our equation, let's take the 0, 4, since that might be easier to work with. Instead of y equals mx plus b, we're going to fill in the corresponding parts to find our b. Okay, so our y is 4, equals our m is 1/3, which we just found, times 0 plus b. So we get b equal to 4. So our equation, y equals 1/3 x plus 4. Let's try 22. We're going to take m equals start with the second point. We're going to go 0 minus 5. 3 minus a negative 7 is going to leave a negative 5 on top and a positive 10 on bottom. If we can reduce, which we can, we're going to make this negative 1/2. Now we plug into the equation y equals mx plus b. Let's take, again, this second point here, 3, 0. 0 is our easy to work with. 0 is our y. Our slope is negative 1/2. The x-coordinate is 3 plus b. We're going to solve for b. 0 equals negative 3/2 plus b. Take this negative 3/2 and we need to move it across by adding it over. We're going to get b equals positive 3/2. Put the slope and the y-intercept now together. Y equals negative 1/2 x plus 3/2. Go ahead, flip over. 25, 26, and 27. Again, are working with points. Number 28, if we need to graph the equation, we can start here. We know that 3 is our y-intercept. So we're going to go at 0, 1, 2, 3, and we're going to put a point. Okay. Now let's find a couple more points that correspond to the values. Since we have a slope of m equals 1, we know the graph is going to go up and to the right. So if I plug in, let's say we plug in 1. Okay, so we're going to go right 1 for x. If I plug in 1 at x equals 1, you're going to get y equals 1 plus 3, which is 4. So if we go over to 1 on the x and go up 1, 2, 3, 4, we should have a point on our line. Okay. Problem is as we go to the right, we're going to be off the graph. So let's go plug in some negative numbers. If we plug in x equals negative 2, well, we're going to get y equals negative 2 plus 3, which is 1. So we can go over to negative 2 on the x and go up to 1, and we have another point. Another way we can do this, if we start on the point, okay, instead of going up positive 1 and right positive 1, let's go down negative 1 and to the left negative 1, or 1, okay, which is equivalent to a slope of 1. So down 1, over 1, down 1, over 1. We have a bunch of points that we can take. If we connect the line, we get this handy-dandy line. 34. Hudson is already 40 miles away from home on his drive back to college. He's driving 60 miles per hour. We need to write an equation, hopefully in y equals mx plus b form, that models the total distance traveled after h hours. What is the graph of the equation? We're modeling, here's the key, we're modeling total distance. So where we have hopefully y equals mx plus b, instead of y, we're going to say we're going a total distance traveled based off of so many hours. So our distance traveled is a function of the h hours. So our d is just like our y based off of hours. So we're going to take our slope, whatever we have changing by the hours, and multiply it by h. Well, if we have y over x, our y is corresponding to the d over h. So if we are driving 65 miles per hour, we can multiply 65 times however many hours that we go, and we could get a distance. But he's already 40 miles away, so we're going to add 40. Okay. So what is the actually graph of the equation? Well, if we have this equation, which is a linear function, y equals mx plus b, then we know that the graph is here in hours, and this is our distance, and we have a straight line. Where, quickly doing this, we know that our y-intercept is 40, so we are at 40 miles per hour. There is a constant slope that's going up at 65 miles per hour. And 36 through 41, we need to find the slope and the y-intercept of the graph of each equation. Okay. Notice, in order to find the slope and the y-intercept, they need to be in y equals mx plus b form. So if we're going to find the slope and the y-intercept, we need to put it in y equals mx plus b form. If we look at number 38, okay, we need to solve for y. So if we first subtract the 6x over, we're going to get 3y minus 12x equals negative 6. Okay. Now we're going to add the 12x over. Remember, 12x and 6 do not add together. They are not like terms. So we end up getting 3y equals 12x minus 6. Now, if we take this equation, we need to solve for y. So if we divide by 3, so 3y divided by 3 equals 12x divided by 3 minus 6 divided by 3, we get y equals 4x minus 2. And that is our slope-intercept equation. From there, what is our slope? We should know that our slope is now 4, and our y-intercept is negative 2. All right. What you're going to want to do is finish all the problems that we did not do together. Wait for a few minutes. Make sure you check your answers. See if you have any questions. Here's a couple answers from the first part. So 1 through 9 and 10 through 15. 16 through 21. And 22 through 24. Here's 28, 29, and 30. 31, 32, 33. Don't be falling asleep on me. 34, 35, 38, 39, and 40. I'm leaving you in the dark on a couple of the other ones. Hey, congratulations. This concludes 5-3B. Remember, do your best, forget the rest. Bye-bye for now.